When I'm solving a rational inequality, I'm going to use many of the same steps that we did when we solved a polynomial inequality. However, in addition to finding the zeros, because that's where our graphs changed directions before, I'm also going to find the vertical asymptotes because in rational functions, your graphs may also change directions at vertical asymptotes. So let's start with one that's already been factored for us, and like we've done before, I'm going to make my number line, and I'm going to include my zeros and my vertical asymptotes. Recall that to find the zeros of a rational function, it's whatever makes the top equal to 0. So in this case, my zeros are going to be -2 and +3. Anything that would make the bottom equal to 0 is going to be your vertical asymptote. So my vertical asymptote this time is going to occur when x is 4. So let's go ahead and get those 3 points graphed on my number line. So I'll have a point at -2. That's where my graph may change directions. I'll have a point at 3. And then I'll have a point at 4. And what I'll probably do for 4 is I'm going to actually make a whole big dashed line, like right down my number line, and label that as my vertical asymptote. Because remember, no matter what, your x value can never be equal to that vertical asymptote. So even if your inequality is leading you to believe that it's okay to be equal to 0, remember that plugging in 4 would never ever be okay. Because as soon as I make x 4, I'd be dividing by 0, and that can't happen. So at this point, I'm going to switch over like we've been doing to my calculator and then try to use my table and my graph to determine what intervals are positive or negative or whatever. So let's switch over to a graphing calculator to figure that out so we can finish answering this question.